Okay, so in question 4, it says draw the line passing through point A that is perpendicular to the line passing through B and C. So just like the last one we did, we found the slope of the line BC. Then we'll find the slope perpendicular to it. Rather than, you can plot them, but you're still going to really have to find the slope anyway. So let's find slope of BC. Different BC from the last question. So C will be my second point, so 3 minus negative 3 over 0 minus negative 2. Be careful of your negatives, right? Your integers. When you're subtracting a negative, it's adding. Can you just wait on that? So that's 6 over 2, which is 3. Funny looking equal sign. Okay, so then an abbreviation for perpendicular is an upside down T. Because think about it. Capital T, the top, meets the vertical line at 90 degrees. So that's what perpendicular means. Two lines that meet at 90 degrees. So it's an upside down T. And so perpendicular, remember, so this is a whole number. It's not representing 3 over 0. It represents 3 over 1. Not that we show it like that. That's not simplest form. But you might want to think about it that way, because when you take the reciprocal of that, it'll be 1 over 3. And then we have to change the sign of it. Negative reciprocals for perpendicular slope. Okay, so now let's plot point A. So 3, negative 2 is A. And use our new slope to find a couple more points. Okay. So we're going to go down 1 to the right 3. Notice how I run out of grid space. I want to fill up that grid with the line as much as possible, but not just by using my ruler. Sometimes we get a little bit off, especially if it's not a ruler, you're just using a straight edge. So let's do the opposite direction, because that's the same as, not that we ever show it this way, but it's the same as 1 over negative 3, right? Because a positive divided by a negative is the same as a negative divided by a positive. They're both negative slopes. So when I think about it that way, my rise is 1 and my run is negative 3. My rise is 1, my run is negative 3. 1, negative 3. And now I can fill up that graph paper better. And so I'll get a line here. Oh, that just moved the whole line to the point, I mean. Yikers, just a sec. Okay, let me try that again. Line here, there we go. I'll have to fix it in a minute, but you can get the general sense. Okay, so okay. And then just put arrows on the end. Yes, yes. Okay, so that would be perpendicular. Now let's look at if we did plot those other 2 points. Negative 2, negative 3 is here. 0, 3 is here. If we join those up, it looks like that grid paper is quite square. And so if we do join that up, I'll do it with a green line here. Because it's given to you, BC. Okay. In the question, B and C are given to you. So if you look at that, it does look to be 90 degrees. Okay, and you can see there the slope is up 6 to the right 2, which reduces to 3. So it didn't ask for algebraic work. It didn't say algebraically determine. So I could have just done the green first, calculate the slope of that, then find the perpendicular slope to find my new line. But if it says algebraically determine, then yes, for sure we would do this method. The green is the 2 points that are given to you, B and C.
Oh, negative 2, negative 2. Oh.
Read the question. Okay, so question 5 says the slope of L1. So L for line, that's often used as an abbreviation. L and a little subscript. It's not an exponent. It's labeling it as line 1, is 5 over k. So we don't know what the denominator is. Slope of L2 is 4 over 3. Determine the value of k if L1 and L2 are, in the first case, parallel. So there's the symbols for it, or you can use the words parallel. Well, what do we know about parallel slopes? Are they the same, thumbs up, or thumbs down? Are they the same?
Well, they're equal. Yeah, they're equal.
Okay, are they equal? The same means the same thing. Okay, yes, thumbs up. So that means that 5 over k equals 4 over 3. Now, it would be really nice if the numerator was 4 or 8 or some multiple of the 4, but it's not. So you can use that cross product property where you multiply each numerator and denominator together. So that means we would get 4k equals 15. Yeah, erasing that is an important thing, right, Finn? Okay, so then dividing by 4. So it's not a nice number really. So even though it's a value in the denominator, it's actually a fraction itself. You just leave it as a fraction, 15 over 4. Just make sure it's always reduced. Unless you're asked to convert it to a decimal or round to a certain value. Okay. Now, if they're perpendicular, are the slopes equal? No, they're negative reciprocals. So what makes it a little bit easier is to take this slope that's given and find the slope perpendicular to it. So the slope of perpendicular to L2 would be negative 3/4. So that's what our new slope has to be, right? If they're perpendicular, they have to be negative reciprocals. So now negative 3/4 has to equal 5 over k. So we have to take the negative reciprocal. Now you could take the negative reciprocal of 5 over k. Doesn't matter, do one or the other. But I like to do the one that's actually the numbers. Makes a little bit more sense to me. Okay, so now when we do our cross product property, oops, we get negative 3k equals 20, and divide by negative 3, and I just show the negative out front, never in the denominator. And that one would be a repeating decimal, so I'd probably never show it as a decimal unless I was asked to round. Okay, so if they are perpendicular, they're negative reciprocal slopes. So if you're missing a value, you take the slope from L2, you find the negative reciprocal of it, and now it must equal 5 over K. Okay. So those are common types of questions about parallel and perpendicular. Now a little bit more of an application. It says, determine the value of y if points A, B, and C are given those points A, B, and C, and it says AB is perpendicular to BC. That's what that means. Perpendicular or 90 degrees, however you want to think about it. So that means the slope of AB is perpendicular, well, yeah, is a negative reciprocal. Well, we'll put perpendicular to the slope of BC. Okay, so now calculate. What is the slope of AB? What is the slope of BC? One of them will have a y in it still. I'm just going to move this. Okay, so then when we do that, that's negative 6 over negative 3, which is positive 2. Or maybe do the other one in a different color so it's easier to see. So slope of BC is going to be y minus negative 4 over 8 minus 2. So that's going to be y plus 4 over 6. Okay, I kind of did all my work in a bad place there. I'm going to just erase that. Okay, so now, oops. So now, the slope of AB is perpendicular to the slope of BC. So just like the last one, I'm going to take the one that has just numbers, the 2, and take the negative reciprocal of it. Then it will be equal to the one with the variable in it. So that's going to be negative 1/2 equals y plus 4 over 6. Okay? So this is the slope perpendicular to AB. And then use that cross product property. So when we do that, I'm going to take the part of the cross that has the y's in it. So it'll be 2 times that whole numerator. So that's going to be 2y plus 8 equals negative 6. Then solve for y. Now, you could be asked this question on a graph, and then you would show your work. You could plot it and figure it out. But no matter what, you have to determine and show work. Okay, so you get y equals -7. Okay, so you're told the two line segments. You're told the two line segments are perpendicular. So find the slopes of each of them. No matter what, just calculate the slopes. They're perpendicular, then they are negative reciprocals of each other. You take one of the slopes and find the negative reciprocal and make it equal. If you do it for both, then you're just saying they're parallel because you're just flipping them, right? And it says they are perpendicular. So that kind of leads in to the next question. Question 7 says, if a triangle has vertices at P, Q, and R, prove it's a right triangle. What does being a right triangle mean? Who can tell me? What's a property of a right triangle, Nevin? 90 degrees between two sides, right? So what does perpendicular mean? 90 degrees between two line segments, right? Or lines. So that means we're trying to figure out if one of the three angles is 90 degrees. Okay? Means are they perpendicular? So we know all the values of the coordinates. So you want to figure out what the slope of PQ is, the slope of QR, and then the slope of PR. It's a lot of slopes, 3 calculations. Okay, so you do that, and then you're going to compare them and see, are any of them negative reciprocals of each other? So you do that right now. Yep, find it. Okay, so those are the slopes of each line segment. So if you take a look, if say you kind of just drew a triangle, okay, randomly, that's not so good. Okay, and then so labeled it PQR. So I calculated the slope of PQ. I got -5/4. I calculated the slope of QR, and I got +4/5. Notice that these are negative reciprocals of each other. If you flip, -5/4 becomes -4/5, and change the sign, it becomes positive. So slope of PQ is negative reciprocal of slope of QR. Sorry, it's pretty slow, just a sec. Therefore, PQ is perpendicular to QR. The line segments are perpendicular. The slopes themselves aren't perpendicular. They're numbers that represent the slope. Okay? So the line segment PQ is perpendicular to the line segment QR. So that means my diagram was a little bit off. Really, it should have been more like this. But I didn't know it was 90 degrees until I did that work. Okay? So once I've stated that, slope PQ is negative reciprocal of slope QR. So that means PQ is perpendicular to QR. Therefore, triangle PQR is a right triangle. So you need to make some statements, right? If you're doing a proof. This is a proof. So you can't just go, yes, it's a right triangle, or no, it's not a right triangle. Okay, and then the last one is a quadrilateral, which means it has 4 sides. It's labeled A, B, C, and D. Is this quadrilateral a parallelogram? Justify your answer. So if it just said, is it a parallelogram, you just say yes or no, however you show your work, but it says justify, so we want to show our work. Think about what a parallelogram is going to look like. So if it is a parallelogram, let's say it's A, B, C, D. When you label a parallelogram, you should go in order of the letters, alphabetical order around the parallelogram. Doesn't matter which way. Obviously, I could sketch this on graph paper if I had it, but I don't. We're doing it in our notes. But I'm not going to, for example, this is not going to be D up here and then C here. It's going A, B, C, D, or the other way around. Howard, can you be quiet, please? So here, A, B, C, D, is it a parallelogram? So if it is, then BC, so is BC parallel to AD? Oh, that looks like DC. Just a sec. It didn't recognize my B. Okay, and then we have to check both pairs. If we only check one pair, then it could be a trapezoid. Remember, a trapezoid has 2 sides that are parallel and 2 that aren't. So we do have to check both. And then is AB parallel to DC or CD? Doesn't matter which order for slope. So we're going to have to find 4 slopes. So slope BC, slope AD, slope AB, slope DC. Okay, so I'll give you a couple minutes to work on that. Okay, so we're going to have to do a little bit more calculations here because conventionally, a parallelogram or any kind of quadrilateral should be labeled in alphabetical order. Guys at the back, focusing up here, please. Pencil in your hands rather than your chips in your mouth. Okay, so conventionally it should be labeled A, B, C, D, but when these notes were made, it was switched around. So if you take a look at it, I did a sketch to make sure that these were in the right place. I did see that AB and DC are equal. Okay, are equal slopes. So if I were to sketch point A is -8, -2 in the third quadrant. B is -5, 3 in the second quadrant. C is 2, 1 in the first quadrant. And D is 5, 6 above it. So yes, this diagram is correct. Okay, when I do that. So I know now that AB is parallel to this side. So for sure that from what work I've done. Where the issue comes in is I found the slope of BC, which is actually a diagonal, and AD, which is actually a diagonal. Okay, so that's because the parallelogram is labeled differently than what we conventionally do. So it is important to check that. That's why I went back to check and make sure. Okay, so now I want to calculate slope of BD and AC. What's the question?
Why is it that with slope in 1 minus 6?
Because I went from D to C.
Oh,
It's the same slope. It doesn't matter which way you go.
okay.
You should have got 5/3.
I'm just saying, you're kind of adding like extra steps on it.
Up to you. If you're going from first point to second point using that formula, I did it the way you're using the formula. So now BD, so that's going to be 6 minus 3 all over 5 minus -5. Reduce that, and AC will be 1 minus -2 over 2 minus -8. Okay, so when we simplify those, we get 3 over 10, and we get 3 over 10. So now those two sides are parallel. So it is a parallelogram. Okay, don't just find the sides and just say, yes, parallelogram. Make a statement to say how you know that. Okay, so just like I did for the triangle one. So the slope of AB equals the slope of DC. Slope of BD equals slope of AC. Therefore, AB is parallel to DC, and BD is parallel to AC. Therefore, ABCD is a parallelogram. Okay, so you don't just say yes or no. It's got to be some kind of explanation of how you know that. You know that because the slopes of opposite sides are parallel to each other, or the lines are parallel, which means their slopes are equal. And I think I was able to fit the word in there. Almost. Gram. I put a period. Okay.